Yeah, fast forwarding is the main achievement that you get over MPLS. Fast forwarding. Forwarding the packet based on the label that it has got, not based on the destination IP address. That I would like to explain you with an example. You see, in our topology here, we got MPLS already ready. It's running. And for all the networks, the labels are not assigned by me. They are dynamically assigned. And let us take this network 4444. For this network, we have a label. When you trace route, you can see that label. Every router provides a label. Sometime it's the same label that everyone gives. But there is no need for all the labels to be same for that network. For example, for 44444 network, which is OSPF given route in our scenario, router 1 will give label number, let's say 19. Router 2 also gives the same thing. Router 3 also gives the same thing. But I'm telling you, it is not needed. It can be different. So when you troubleshoot, this is the main point that I'm trying to emphasize. When you troubleshoot, don't expect labels to be same. If it is different, that is not a trouble at all. That is not a trouble. If router 2 says 29, if router 3 says 49, it's okay. For 4.4.4.4, each router has generated a label. And this label is from 16 onwards. From 1 to 15 label numbers, number 15, 14, descending to 1, they are reserved for internal communication, for some signaling between MPLS routers. Later, we will learn label number 3, the purpose of label number 3 for which it is reserved. We call it as PHP, penultimate hop popping. Later, we'll not talk now. So what I'm coming to say here is label number 1 to 15, you won't see anywhere. They are internally utilized. Only from 16 onwards, every router just dynamically they assign. They're not really copying from neighbor. But sometimes, surprisingly, all the routers have got same label for a network. Right? In a small network, you can see that. In a large network, very rarely you see that. But in a small network, it is very easy to see similar label for same network, same destination on all routers. Fine. If it is same, no problem. If it is different, no problem. So, okay, now, what about this router 4, he's the owner of that network, no? He's the owner of the network. That router will use a special label from the reservation, which is label number 3. So router 4 will have label number 3 assigned for all the networks, not only this 444, for all the networks that are directly connected. What is that label number 3? It is called penultimate hop pop, meaning if a packet is coming from here to here, this is the ultimate hop, what I'm drawing now, isn't it? It's the ultimate hop. From 3 to 4, if the packet is jumping, that's the last jump. Later it's not going to jump. It has reached R4, the destination where 4444 is. That's the ultimate hop. Okay. If it is an ultimate hop, what needs to be penned, what needs to be done is you need to pop the label off. Stripe it off. You need to pop the label off. Remove the label and send as an IP packet. That is what label number 3 here means. Router 4 will tell router 3 that I got label number 3 for 4444. Immediately router 3 gets a clue. What clue? Router 3 gets a clue that R4, the next router, is the last hop. There is no other hop. Just to inform R3 that this is the last hop, this number 3 is used. The label number 3 is used. Okay. Why should router 3 pop the label before sending to router 4? To understand that, we need to understand something more. We'll do that. Now, before that, I would like to tell you a very important thing, that this MPLS header, which we saw in the Wireshark in the previous class, it is only 32-bit size, and we all know the single IP address itself is 32. But here we see the entire MPLS header itself is only 32, and that is more than enough, sufficient for router to decide on the destination network. Now, this 32-bit is not going to be used for label. In this 32-bit, the first 20-bit is for label. So out of 32, only 20 is for label, which means 2 to the power of 20. This is the maximum, this is the range. I told you label number 16 to 10,000. No, it's not 10,000. 10 lakh. 48,576 labels. This is the range. These many labels. These many labels are available on every router. Do you have these many networks in a router? 10 lakh routes? Not really. We don't have 10 million. In Indian language, we say lakh. It's 10 million. 48,000.
No, Jay, that's 1 million.
Oh, sorry, 1 million. Okay, 10 lakh is 1 million. Okay, 1 million Indian language. 100,000 is 1 lakh. Okay, so it's 1 million. 1 million routes in a single routing table? No, not even ISP has got that big. Because we do summarization, we have stub networks, and we have much more to reduce. Label number 16, only it starts, and this is the maximum you can go. Means labels assigned. Again, I'm not telling that these means 1 million labels are going to be used. There are some reservations again, even between 16 to 1 million. There are some reservations for segment routing, which we'll learn later. Segment routing is also using the similar concepts, like using labels and segmenting based on label. That's why it is called segment routing. So some labels are reserved for segment routing. Global prefix, adjacency prefix, something like that. Now, out of 32, 20 is for label, and next 3 bit is for experimental, meaning it can be used for anything. It is used to mark the QoS. It is also used for traffic engineering. It can be used for any other purpose if you want. As of now, we use it for COS and TE, traffic engineering, TE bits. So in general, it is called as experimental bit. If you are using for QoS, then it will be called a COS bit. When you are using for traffic engineering, then it gets another name, TE bits. But it is the same bit, which can be used for any one of this. 3 bits. So 23 is gone out of 32. Next, 1 bit, we call it as bottom of stack. We know what is stacking, keeping one above the other. I took one bundle of American dollar, $100, one bundle, and I took another $100 American dollar only. I don't want Singapore dollar. Another bundle. I stacked it on it. So I keep stacking. the bundle, one above the other, stacking. How do you know that which I am holding now is the last bundle? When I touch, I can feel that there is a table under. When I keep my hand on top of this, I know it is not lost. This is not the last bundle. After removing that, when I keep my hand on this bundle, I still know there is another bundle. When I keep my hand on this bundle, after removing the above two, I know very well that this is the last bundle because my fingers can touch, my wrist can touch the table. And inside my palm, this bundle is. So the feeling, the touch feel of the table says this is the bottom of a stack. Likewise, there may be many layers of MPLS in a packet. The receiving router needs to know that I am processing the last MPLS layer or second last. How it knows? If it finds this bit 1, I said there is only one bit reserved. If that bit is on, which means this is the last label, the one which the router is processing is the last label. There is no other label to process. When the router processes this top label, the bit is going to be 0. The bottom of a stack bit is going to be 0. So router knows very well that right now I am not processing the last label. There is another label to process. So this one bit is to tell the router that you are processing the last label or not. If it is on, this is the last label. If it is not on, there are many more labels. So this is bottom of a stack bit. Just one bit. Next. Why do we need this multiple layers of MPLS is your question. See, one will be for VPN, one will be for hop. Let me repeat. VPN is from here to here. So for the virtual next hop, there is one label. For this router, there are two next hops. One is the physical next hop, you call it as transport label. The other next hop is through the tunnel, the virtual next hop. For that, you need another label, another layer of MPLS. Transport service. So this is transport, this is service. So service MPLS label, transport MPLS label. If you have traffic engineering, then also you will have another layer of MPLS. So I have just explained you the reason why you need more than one layer of MPLS layer. Now at last we have 8 more bits out of 32, which is for time to leave. See, TTL is seen in layer 3 header, but this MPLS comes before layer 3. I was explaining you saying that it is intermediate, it is in between layer 2 and layer 3. I was saying that this is 2.5 layer. I was also saying that if this layer 2.5 is there, then the routers will not look into layer 3 header. If 2.5 layer is already giving you where to send the packet, the information where to send the packet, why it will see the layer 3 header? But the TTL is in layer 3 header, which is important for routing. So what it does is, what MPLS does is, it copies the TTL from the layer 3 header down to this MPLS header. In short, what I want to say is, two main things that are needed from a layer 3. One is the destination, the other one is the TTL. Now, because you enabled MPLS, you are not compromising with TTL. To say which destination you got, label. To say which destination you got, label. And to avoid loop in layer 3, we have TTL. The TTL is copied in MPLS. So you still avoid loop even though you don't see layer 3 header. Is that clear, or should I explain you again? See, time to leave in layer 3 header, have you seen? TTL in layer 3 header. Have you seen layer 3 header? Why silent? You have not seen?
Yeah.
You have seen. Okay. That TTL is for avoiding loop in layer 3. But now, after enabling MPLS, we have decided not to use layer 3. That's why we enabled MPLS. So if loop occurs, it needs to be stopped. That is why the TTL from layer 3 will be copied to MPLS header, so that inside the MPLS domain, the TTL will get decremented. And again, when it goes out of MPLS domain, the decremented value will be copied from MPLS header back to IP header. Fine. So this is how the 32-bit reservation for MPLS is segregated. 20-bit, 3-bit, 1-bit, and 8-bit. In total, it is 32-bit. Now going back to our penultimate hop popping, PHP.
I have a question.
Yes, question, sir.
Go back to
The picture. Yes.
you
Yes.
say one is for the service, one is for the
Transport.
if you need more about traffic engineering,
Mm.
then you will have one more.
No. Traffic engineering is a VPN based on the policy. Traffic engineering is not another VPN. See, here I have written service label. Traffic engineering is the service label. You can have VPN with policy, without policy also. Without policy is like normal routing over the virtual tunnel. With policy is like You got multiple tunnels, and policy says you need to use a tunnel which is having bandwidth of 10 meg.
What do you mean by traffic?
Just I finished saying that. Let me repeat that. Without traffic engineering, your traffic will go as per the routing table. Routing table says use this VPN and the packet will be forwarded. Traffic engineering is I see more than one route. Routing table says go via route A, path A, but the policy says you need to use the path whose bandwidth, available bandwidth is 10 meg. That available bandwidth 10 meg may not be available in the route given by routing table. But there is another path which is not in the routing table which suits the policy. So the packet will be using that path. Traffic engineering, if I need to repeat now in another word, another sentence, traffic engineering is choosing a path as per your policy, not as per the routing table. Your routing table may say a path which may not meet your policy requirement. Traffic engineering will know the route given by routing table, will also know the route that are available because we use link state routing protocol. You know OSPF? It's a link state routing protocol. It has got all possible route information in the database. Traffic engineering can access the database. And traffic engineering will say, fine, see routing table, thank you for your support. The route that you provided is not actually enough for me, not meeting my need. Let me use another route that is there in the topology table and form VPN. So it forms VPN with a route provided in the seen in the database, not in the routing table, which is also VPN. You're not using two VPNs here. You have either this or that, meaning traffic engineering or routing table. So you will not have three layers when you have traffic engineering. You'll still have only two layers. Service level is what going to be traffic engineering. Yes, go. Question.
What do you say last?
Service label, no? Service label. Service is what going to be used by traffic engineering. If you don't have traffic engineering, then service is going to be as per the routing. LDP neighbor. Aha, there is a problem between R1 and R2. There is no MPLS. So let me go and enable MPLS. No, let me check whether it is here. Show MPLS interfaces. There is no MPLS. So let's enable MPLS. MPLS IP. Interface G3/0. MPLS IP. Boom. Now I'm expecting. Okay, see LDP neighbor has come. Now let me trace route. Wonderful. You see, I got label. This is an output on R1. it says label number 20. Before sending to R2, it puts label number 20 and sends. And R2 before sending to R3, it puts label number 22, which means the local label here is 22. The local label here is 20. And here the local label I don't know because that's not needed. R1 is forwarding the packet to R2. I need to know the packet to whom I forward. I need to know the label to whom I forward. And you see when it is sending to R4 there was no label because it is PHP. It do have MPLS. Let me show you on R4 if you go and check MPLS, you do have an MPLS neighbor. You still have an MPLS neighbor. Now let us go and confirm what we have learned. Based on this output, I am telling you that router 2 is using label number 20. Is it true? Let me show you. Go to router 2 and say show MPLS LDP or MPLS forwarding table. You see for 44444, the local label is 20, correct? That's what I have written. And the outgoing label is 22. That's what you see here. Outgoing label is whose label? R3's label. This outgoing label will be the local label for whom? The next hop, which is this guy, router 3. Go and check. On router 3, show MPLS forwarding table. You see, for 44444, the local label is 22. The for 44444 on R3 local label is 22. Outgoing label is popping. Why? Because it received label number 3. R3 before sending the packet out, it has popped. That's why you don't see any labels before while it is sending to 4. There's no label. Because according to R3, it knows that I have to pop the label before I send it to R4 via G4/0, which is towards the downstream.
Jay, so the pop label, we could able to see this when we are doing the white shark, right?
No, you cannot see. How you will see? There also you will not see. At least here it says it will be seen as only normal IP packet. That's all. There won't be MPLS. That's all. You cannot see some packet flying away, some layer flying from. You cannot see those things. When you capture between R3 and R4, it will be normal IP packet. When you capture between R2 and R3, you will have an MPLS for the same packet. That is how you can see.
Yeah. This is something you have 19. That's pop. You have 20. You have 20 and then 17.
Very good. Listen. Why for 2222 it is popping label? I am in which router now? Tell me. I am in which router now? For 3 to reach 2222, it is just one hop, right? This is the owner of 2222, isn't it? That is why it is popping. For 2222, it is popping off. You understand? What else? For 10.12 also it will pop off because that's for 10.12 this is the ultimate jump. If a packet is coming from this direction, 10.12 is here. It's ultimate jump. That's why it is popping. Which one? This 17? This 17?
Yes.
You know it. You know it. For one network, is it one hop away from R3? No. One network, is it one hop away from R3? What is PHP? It should be an ultimate hop. You're not answering my question, but now you're saying yes. See, listen. Is 11111 one hop away or two hop away? Answer no. Is it two hop away or one hop away? For R3, how many hop away? Hello. How is it one? For R
It's 2, right?
for R3, this is one,
R2
and this is two hop.
the second hop.
Okay, no, yeah,
No, please answer the question. We will come to that question, your thing later. Ko, answer me. For R3 1111, is it one hop or two hop? Again, you are saying one. How it is one? 1111 is here. R3 is here. How it is?
I mean, direction. I'm confused what direction. You go to router 1 or you go to router 4?
Your question is about not 4. Your question about 11111. What is the direction? This is the direction for 11111. For 44444, this is the direction. We are not talking about 44444. You asked me about the 17. 17 is for which network? Tell me, 11111, how many hops from R3? What is PHP? It is for one hop, right? Not for two hop. If any destination is one hop, like 22222 is one hop. If any destination is one hop, then it is going to pop. 10.12 is also one hop. See, 10.12 is here. Just one hop. That is why it is popping. 4444 in the other direction, 4/0 direction, it is one hop. That's why it is popping. But 11111 is not one hop. It's more than one hop. That is why it is using the label given by R2. According to R2, the local label is 17 for 111. Let me show you. According to R2, for 1111, it is 17. See, router 2 is popping the label because for router 2, 11111 is the immediate hop, PHP. Take your time, go through this video.